Hi, Assalamualaikum. Today our group will present on application of differentiation, which is related rate, applied maximum and minimum, Ross theorem. First, let's meet our team members. Number 1 is me, Sharifah Nushamiliana. Number 2 is Tuan Noor Aisyah. Number 3 is No Ain Balkis. And the last one is No Izni Rosli. I will start this presentation with the meaning of differentiation. What is differentiation? Differentiation is method of finding the derivative or rate of change of a function. What are related rates? Related rates are a problem where we reason about the rate of change of a quantity by using information we have about the rate of change of another quantity that's related to it. Then, what are maximum and minimum problems? Maximum and minimum problems is finding the largest and smallest value of a function within a given range. Next, we move to Ross theorem. Ross theorem states that the derivative of fc equals to 0 only if fx satisfies the following conditions, which is the function is continuous on the closed interval and the function differentiable on the open interval and fa equals to fb. Then there exists a value x equals to c that will make a derivative of fc equals to 0.
Related rates.
When it comes to the first topic, related rates, there are a few steps you can use in solving problems related to the topic. For example, you can first draw a diagram if possible. Secondly, introduce a notation. Thirdly, express the information and the required rates in derivative terms. And after that, you can write your own equation related to the problem so you can answer it easier. And then you can use chain rule or implicit to differentiate both sides of the equation respecting to time t. Lastly, when you've got all of that down, you can finally solve the derivative and answer the question. Here I have with me an example question where it says the volume of water in a hemispherical bowl of radius 60 centimeters is given by V equals 1 over 3 pi parenthesis 36x squared minus x cubed, where xcm is the depth of the water. If the water is poured in at a constant rate of 20 cm, at what rate is the level rising when the depth is 8 centimeters? So the necessary solution to this problem is to first take out all the info you need and try to figure out which info goes where so you can answer the question easier. As you can see here, I took out the general terms first: V equals volume, X equals depth, R equals radius, and then I took out R equals 1 over 3 pi, and dV over dt, which is something I need to find dx over dt, equals to 10 as given in the question. And finally, I took out the volume equation, which is also in the question as I mentioned before. And finally, I also took out dV over dx, which is the differentiated version of the volume equation, which equals to 1 over 3 pi parenthesis 72x minus 3x squared. Now, when you've got all of that info down, you can finally go for the main issue in the question, which is to find dx over dt. In order to find dx over dt, you would need to use the equation dv over dt times with dx over dv. And since we already have all the info in which x is basically 8, as it's mentioned in the question, as x equals to depth, and the answer wants to know at what rate is the level rising when the depth is 8 centimeters, that x dx over dv, 8 differentiated, would become 1, or x. So basically 1, okay. So to calculate the equation, it would be 10 times with 1 over 3 pi, 70 parenthesis 72x minus 3x squared, and then you can put in the x values, and finally you will get the answer, which is 0.025 centimeters.
Rolle's theorem.
These are the steps for solving Rolle's theorem problem. First, we need to find fa and fb by substitute the interval value in the given equation of fx. Second step, FA must be equal to FB. Next, we need to differentiate Fs, which will become F prime S, then it will be changed to F prime C. For the fourth step, the differentiation of F prime C, we substitute into equation F prime C equals 0. Last step, we will simplify the solution and calculate the value of C. To understand it more, let's look at the example. To solve the problem, we need to find FA and FB first. FA is equal to F1. Then, we substitute the value of 1 into Fx. So, we will get 1 squared minus 4 multiplied by 1 plus 3. We simplify it and we get 0 as the answer. Next, we find FB. FB is equal to F3. We substitute the value of 3 into Fs and we get 3 squared minus 4 multiplied by 3 plus 3. Solve the equation and we will get 0. Keep in mind that FA must be equal to FB. So, when we compare F1 and F3, it has the same result, which is 0. For step 2, we need to differentiate Fx. After differentiate it, we will get f prime x equal to 2x minus 4. Let's move to the step 3, which is we need to find f prime c equals 0. First, we need to convert f prime s to f prime c. Then, we will get f prime c equal to 2c minus 4. Next, we make one more equation, which is f prime c equals 0. We simplify the equation and we will get 2c minus 4 equals 0. Then, we solve the equation to get the value of c. So, for the final answer, we will get c equal to 2 equivalent to interval 1, 3. The answer is correct because value of c is between interval 1, 3. So, that is all for the Rolle's theorem. I hope you understand my explanation. Thank you.
So, the conclusions that we can make from the application of differentiation is differentiation helps find rates of change, and it is useful for determining maximum and minimum of a function. Differentiation also is used to solve optimization problems.
And that's all from us. Thank you for watching.